In this session, I am going to start with the hands-on practice using Python. And for that, because we are not going to start with the installation of the Python. So for this particular session, we are going to start with the Google Colab. Now, how to use with the Google Colab, and the main because the main purpose of this workshop, it is not possible we will be able to cover all the topics in detail in 2 or 3 days. It is not possible. So the main purpose of this workshop and particularly this session is just to make you familiar with this particular platform and how to start with the basic fundamentals of image processing, so that in future, or if you want to start with image processing, so you can start with that. Okay, so that is the main purpose. So how to start with the just let me share my screen. And since it's hands-on practice, so it would be great if you at the same time along with me, if you also try to implement the course. Okay, so if you open your if you simply open your Gmail, right over there, if you see my screen over there, you know how to open your Google Drive, right? So if you simply open your Google Drive, right, and over there if you simply click on this over here, if you click on this new, and if you go to more, then you will be able to see this Google Colab directory. Okay, so if you simply click on this particular thing, it will just open the notebook, Python notebook on Google server. Okay, it is on Google server. And the best thing about this particular platform, is that you might have heard about GPU and TPU type of a system. Means the processing speed of GPU system, it is far more in comparison to CPU. And most of us, the laptop that we have or the system that we use, they simply have CPU. Okay, and for the image processing, especially when we include machine learning and image processing together, for that we need a high processing system like GPU. So that GPU is also available in this Google Colab. So that is the best part. Second best part, we do not need to stuck ourselves how to install Python and how to install different packages. Okay, so simply we need to open the Google Drive, and from the new button over here, simply we can select the Google Collaboratory, right? And this will simply open the page, and over here you can write the codes, right? If you just click on this runtime, and if you come to this change runtime type, okay, over here you can select the option. If you want to use GPU or TPU, you can use it. Means if you select GPU, then the processing will be done on the GPU system that is available on the Google server. Means all the processing, it will be done on the Google server. On our side, we are just going to write the code. Once we click on the run button, then that code will be executed on the Google server, and whatever output whatever output we get, that will be displayed on this platform, right? So all the things are going on the Google server, right? So presently, we do not need CPU, we do not need GPU, so simply I select none. Okay, and I simply click cancel, right? Over here, the main thing, over here you can see these two tabs, right? The purpose, as it is mentioned, and most of you might be knowing that notebook, Python notebook. And when we say notebook, then the purpose of calling it as notebook is that over here we can write text as well as code. So suppose if I want to write some text, simply I will click on this text button, and I can write anything like workshop on image processing will be learning, right? And I can do the different type of formatting, whatever I want to do, right? So, and you can see the result is over here. Now after this, if I need to write a code, simply I need to click on this, and this will just allow me to write a code. Simply if I write a equals to 2, and if I click on this, it will simply execute a equals to 2, right? So it is going okay. So if I simply write print a, and now if I run, then this is the result, this is the value of a, right? And in the text box you can see that if I do double click, then it will again allow me to do the editing. Okay, if I click outside it, then it will just display as some heading. If I do not want heading, or if I simply write without a bold, then it will be a simple text, right? So this type of thing, because in this we can add text, we can add code, so it is the reason that in Python we used to call it as notebook, Python notebook. Okay, and this is the platform is Jupyter Notebook, and it is there in Google. Right, now to start with a Python. Okay, now to start with a Python, because like we are going to do image processing, and to do the image processing, the first step is that we need to take the input, right? And the input can be taken either using the webcam, or we can read the since we are using this Google Colab, and as I told you that all the processing is done on the Google server, it means that if I need to read any image, then I need to upload it on the Google Drive. Okay, it is not possible that the file is stored locally on my system, right? It is not present in Google Drive, means it is not present in Google server, and it is not possible if the file is not present in Google server. I cannot read that particular file using Google Colab, right? For that I need to upload the image, right? Secondly, I need to connect my Google Drive with this Google Colab. So how I can connect my Google Drive files with the Google Colab? To do it, simply I need to click over here. If you click on these triple lines, it will just open this, and if I click on this, so, and if I bring my cursor over here, then it is uploaded to session storage. It is refresh, and it is mount drive. Simply if I click on this, you can see mounting Google Drive and permit this notebook to access your Google Drive files. So simply I need to click on this. When I click on this, it will open this, and over here I simply have to click over here, and this will just pop up this window. Okay, and over here I just need to, the window that is going to open over there, I simply need to click on connect to Google Drive, and then it will start mounting. Start mounting means it will simply connect my Google Colab with the Google Drive, right? So and once it is connected, once my Google Drive is connected, now you can see this another folder, it appears over here, and if I click on this arrow, it will simply drop down my drive and the folders that are available. Like you can see, the complete list is available, right? So simply if you click on this, then this, it will simply connect your Google Drive with the Google Colab. And the purpose of this is that by doing this, we will be able to read the image that is present in our Google Drive folder, right? So it would be great, like if you open this Google Colab and try to connect your Google Drive with the Google Colab. Okay, and then we will start with the next step. The next step will be to read the image from the Google Drive. Okay, so start this, and then after 5 minutes, then we will start with the next step. Okay, and participants, if you have any doubt, if you struggle with something, do ask me. Okay, because it's hands-on session. So if you find any problem, simply ask me, and you can even share your screen. Yeah, I will share the recording. After all the sessions of the workshop, at the end, in the next week, I will share all the recordings. So participants, just try to complete it, and then after 4-5 minutes, then I will start with the next step. मेरे को बता देना। Okay, so I hope everyone has completed that task. So is there anyone who have any doubt? Okay, so in the next step, because we need to read the image, and since our main purpose is to clarify the fundamental concept, so over here we are going to first create an image using paint. Okay, so just let me share my complete uh, entire screen. And now over here, if you simply open the paint, okay, first we are going to create some ideal image, so that like when we are going to apply some fundamental image processing, so that type of thing, like we will not stuck with the complexity of the image. So we will keep our image simple, okay, less complex, and over there we will try to apply some image processing. Okay, so this is a white background. Now over here I will simply put some circle, and let me as I told you in the morning session, that if you click on this edit color, okay, and using the edit color, like if I simply, you can see if I move my cursor, so these numbers are changing RGB. Okay, so over here if I simply select this R as 255, this green as 0, and this as 0, so it is going to be the pure red color. So simply click on red, so it will make this circle red, and let me fill it. In the same way, let me take another color, another circle, and this time let me take another color and let it be pure green. Okay, pure green. So I am going to have a pure green circle and this. Okay, and let me take another circle, and this time the pure blue. Right, okay, and then I can create this circle over here, and let me fill it with this. Right, and now I can save this image. Let it be A1 PNG and save. You can't save to another location. Okay, so documents and save. Right, now if I open this, now this image, it is on my desktop. Okay, and as I told you that for the Google Colab, if I want to read an image from the Google Colab, I need to upload this image on Google Drive. Right, so I am going to open my Google Drive. Okay, and this is my folder. So over here I am going to drag this image, like I can drag this image directly over here, or like now you can see it is on Google Drive, right? Or simply if I can upload the file using this, it is all up to me, right? So this is the image that we have created, and now we will try to read this particular image using the Google Colab. So if I again open this, and now if I go to my Google my Drive, it means I need to come to this particular location. So if I open this, my so my image, it is present over here, a1.png. Now over here you can find these three dots. If I click on this, left click, if I left click on this, over here options will appear, and from here I can select this copy path. So simply I will copy this path, right? And like suppose if I just to check what is there in the, so this is the path, okay, that we have copied from here, right? So this is the path for the image. Now to read an image, to read the image, or for doing any image processing task, we need some inbuilt functions. So there are different type of packages available. Over here we are going to discuss the OpenCV. Okay, so for the OpenCV, like like these are some of the packages that we need to use for this particular workshop. The first package, it is this import cv2 as cv. Now when I mention import cv2, it means that by writing this import cv2, I am just giving the instruction to the compiler that all the files that are present inside inside this package, that need to be included. Import cv2 means all the inbuilt functions, objects, or everything will be imported. And as cv means with the alias name, that import all the files from the cv2, but the name should be cv. It means whenever I want to use any inbuilt function of cv2, I need to put, instead of writing cv2, I will write cv. I will write cv. Another package that I need to use, it is matplotlib, and over here I need to use just pyplot to plot the graph, to plot the image. Okay, so for this I simply import this package and with the name plt. So in future code, whenever I use to write plt, it indicates that I am mentioning this. Okay, it means this is another name, alias name for this. Third is import numpy as np. Now in the morning session I told you that the image, it is just a matrix, right? And it is just a matrix. And when we do image processing, it simply means that we are just manipulating the matrix. We are just checking the similarity of the matrix element, or we are doing some manipulation to produce some fruitful output. Right now, numpy is a package that is related to array. Okay, and array, it simply means matrix. Okay, so over here, by importing this,
sorry, since you are 13 का period,
I do.
Okay,
so over here, import numpy as np. Over here, it simply indicates that we are importing the library functions that are related to the matrix. Okay, because our image is matrix, it would be great if we do all the calculations in matrix form. Remember, if we have 5 by 5 matrix, okay, so and if I want to add 2 matrix of 5 by 5, then if I simply do the matrix mathematics, or if I use the inbuilt function that allow me to add 2 matrix, okay, so that will take less time in comparison to if I prepare my own functions. The reason is that this numpy file, it is written using C type of a language. Okay, that is very less complex in the sense that takes very less time in comparison to writing a code on Python. Okay, so it is always better to manipulate matrix directly, and that can be done using this numpy. Next is system, this import file, and this one, it is especially for the whenever we want to display an image, because as I told you that whatever programming that we are going to do, it is on the Google server. So if we want to display an image using CV, using this OpenCV function, then it is not possible. It will say, like in the past, like it crashes the Google Colab. So Google, they create their own code, own function, and using this particular function, we can display the image without any difficulty, without crashing this particular platform. Okay, so these are the files that you need to import. Now once we import the file, right, now if I simply let me click on this, once you import all these files, simply over here you will find the play button. This is a run button. Either you can press this and it will start executing this particular code. Okay, And when it is going to execute completely, that this circle, it will be replaced with a tick sign. So let us complete this execution. Okay, so you can see over here tick sign is there. Now to check the latest, like suppose if I want to check the version of this, so to check the version, simply you need to write this in Python. Simply if you write print and inside the bracket if you put anything, then that will be printed. For example, suppose suppose if you simply write print and within the bracket ABS, and if you execute this, and it will print ABS. So whatever you are going to put inside the brackets, that will be printed. If like if A equals to 2, and if I put over here A without inverted commas, so and now if I run this, so it will display 2. Why? Because over here I mentioned the variable name. Okay, since it is not inside the inverted code, so it will just display the value of this particular variable, right? Over here, similarly, we can, to check the version of this particular package, is simply I can write cv dot underscore version underscore, and if I simply run this, it will display the version of this particular packages. Right? Now after this, our task is to read the image. To read an image in OpenCV, we have this function cv.imread. Most of the image processing related functions, they start with IM. Okay, so IM stands for image. So image read, right? So the function, for this function, we simply have to first we call the function, then we put a dot, and then we call the function name, and inside the bracket and inside the quotes we just have to mention the address. So what address we need to mention? The address that I have copied over here, this address, copy path. And if I simply put my address over here, okay, and if I now run this, I will explain the remaining part of the code later on. But you can see the image that I have created. Okay, over here I have created this image. So that image I am able to read. Right? So simply to read an image, I just have to use this particular function, and inside the bracket, inside the quotes, I have to provide the complete path of the image. Right? Now after providing this, now it's the duty of the programmer to check whether the image is read or not, because there may be a problem that this particular file is not present. So in that case, this code will be executed, right? It will not generate any error, but there will be nothing in this particular variable. So it will be the duty of the programmer to check if the image is read properly or not. So to check that, simply we can put this condition. If img1 is this function, so we can simply write if img1 is none. So over here we are just checking if img1 is none, means img1 has something or not. Okay, so if img1 is none, then we are going to print this instruction that we do not read the image. Okay, otherwise we will, if this condition is false, then this will be executed and it will simply print success. So you can see this success. So over here, by checking this, we make it sure that the system, this particular function, has read the image properly. Okay, and why it is required? It is required because suppose if the image is not read properly, suppose if I change the path and let me put this, I know this particular file is not present in my in my drive. So now if I execute this thing, so you can see it simply write could not read the image, right? If I try to display the image, so you can see it shows an error. Why? Because the image, the variable that I pass over here, it does not contain any image, and since it does not contain any image, so it simply display an error. So to avoid this, what we can do, we can put this command over here, so that the image will be displayed only if the image is read properly. So now if I execute this particular thing, that it is not going to generate any error. But it simply write could not read the image. If the image is proper, like A1, now if I read this, then it will display the image, success and this, right? So that is the purpose of this. Now to display the image using Google Colab, the command is this cv._imshow, and within the bracket we need to mention the variable name that contains the image. Okay, that contains the image. If you are not using this Google Colab, in that case you need to mention this code. Over here, because as I told you, this command is required because Google Colab was having a problem with this file, with this command. So to avoid that problem, Google Colab, they designed their own function, right? But if you are using Python on your system, then this will work. You just have to mention cv.imshow, and within the bracket, first you need to mention the name of the window, okay, comma, the name of the variable. After that, this image will get displayed in a new window, right? And after that, the purpose of this particular, it is to, like, the window will get displayed, okay, but at the end you need to close that window programmatically. Okay, so to close it programmatically, with this you are just going to check whether you are just going to ask the user to give the input if the user want to close the image. So with the help of this, when we execute this, the compiler will wait for the user to give an input, and whenever if the user press any key on the keyboard, then immediately this will be executed, and the window that is opened, that will be closed. So to display the image on using the Python installed on your system, you need to execute this 3 lines. Is it okay? Any doubt? So, sir, let me read the questions. Sir, can you please repeat the steps again? Yes, if you have all these hands-on activity in written form, please share with us. It may be easy for us, otherwise it is hard to follow. Sir, you can please share the code in a chat box so that we can keep in pace with you. Sir, you can share with the hands-on. Okay, so this code, of course, I will share, but I will be able to share this code, this complete notebook at the end of the workshop. But of course, I can share this code. Okay, so I am just copying this. Okay, and I am going to put it in the chat box so that you can copy the things from the chat box. Is my voice clear? Because some are saying that my voice is not proper.
It is audible, sir.
Oh, okay. So this is the package. and let me copy this code. This is to check the version. And this, if you are working on Google Colab, then it is going to work, this code. Okay. And if you are working on your system, then this is going to work. Okay, so participants just try to run this code, and then after 3-4 minutes, then we will start with the next step. So over here with this code, with this, I am read and I am show. You will be able to read the image. You will be able to display the image. But remember, this step, it is quite important. Okay, because if you need to check whether your compiler, your platform is able to read the image properly or not. If it is not able to read image properly, then you cannot execute this command. So it should be executed conditionally. Conditionally means it should be executed only if the image is read properly. You just a minute. Listen. We have like in the another system we are also hearing the audio, if the audio is proper or not. So but it is proper on our side, so there may be some internet problem from your side, but from our side, like there are offline participants also, so there is no audio problem. And some participants are
You
also
are audible.
writing that
Audible.
okay, thank you. So participants try to execute this code, and then within 2 or 3 minutes, then I will start with the next step. And remember that the basic purpose of this tutorial, this session, is just to make you familiar with this particular platform, so that all the like all the image processing concepts you can execute, you can do on your own. Okay, because start is always the problem, and once you get started, yeah, then it's difficult to stop. Also in Python, if you want to put any comment, okay, means any comment means you do not want compiler to read that particular thing, then simply put hash. Okay, so if after writing this hash, if you put anything after the hash, that will be considered as a comment. participants regarding whether I am audible or not, because to some I am audible and to some I am not audible properly. But because it is not because there is only one way, so if it is audible for some, so it must be that your internet is not working properly, so you need to check your internet, and that's only I can say. Participants, have you completed with this step? हो गया आपको? Okay, so now going to the next step. Over here, like whenever, like it is not only related to images. In fact, whenever we want to write any program, any computer program, then the first step, it is always that we ask user to give some input. Okay, over here we are giving the input in the form of images, right? After taking the image as an input, then we are going to apply some processing. It may be anything, and after processing, then we are going to display the result. Okay, over here we are going to display the image. Now I told you that if you are using Google Colab, you can use this function. If you are not using Google Colab, if you are using Python install on your system, you can use this 3 lines. Apart from this, as I told you in the package, we have this package also, and with the help of this we can do the plot. We can plot the graph. Over here, image can also be displayed using this particular function. Okay, so the function inside this package, over here the alias name is plt. So to use this to display the image, simply you need to write this plt.imshow, and this will be img1. This presently you can remove this. So if you execute this particular line, it will display the image like this, right? It will display the image like this. Let me copy paste this particular command on the chat box. Okay, so I put this command in the chat box. Now when you execute this command, one thing, if you note one thing, then over here the circle is red, but when I display this image using this command plt, this circle, it is blue. This remains green, and this lower one, it is blue, because the image that I have created over there, originally lower one is blue, right? But when I display the image using this plt.imshow, over here this image, it is red. So why is there is a difference? The difference is that, as I told you in the morning session, that when we read the image, okay, or for the color image, we have 3 components: red, green and blue, right? And for the red, like if we are using the grayscale image, then it is simply the gray image, and for the gray image we just need 2-dimensional matrix. But if we want colors, so for the colors we need 3 2-dimensional matrix, one for the red, another for the green, and the third for the blue. Means we have 3 layers that makes the matrix 3-dimensional, right? Now over here in OpenCV, this particular function package, it reads the image as BGR format. Means it consider the first layer as blue, second layer as green, and the third layer as red. Whereas so it is the reason that we read the image in BGR format: blue, green, red. Okay, and when we use this particular function, it is displayed in BGR format itself, right? There is no change. But when we use this particular function, so it is going to take the first layer as of the red, okay, second as the green, and the third as the blue. So OpenCV, it is reading the image in BGR format, but this plt.imshow, it is reading the image in RGB. Okay, so it simply swap the position of red and blue. So it is the reason that when we display this img1, because img1 it is read using OpenCV, so the first layer it is of blue, first layer of img1 it is of blue, second green, and the third of red. Okay, and so it displayed properly when we use OpenCV function. But when we use plt, since the first layer will be considered as of red, okay, so the blue one it is displayed as red, because the blue layer it is considered as of red. Green, BGR and RGB, the position of green it remains same, so it is the reason that green it remains same. And the third, or it is read, or in OpenCV it is read in BGR, so the third layer is of red, but in this plt third layer is considered as of blue, right? So it is the reason this pure red color it is displayed as pure blue color, right? So you need to now if we do not note this particular thing, right, so the complete image will get changed. Because like suppose if I want to classify the these circles on the basis of the color, then I will misclassify. Originally this one is red, but because over here this one is displayed as red, so the complete task will get wrong. So I should be clear that whatever package that I am using, that I should know that in what format that particular package is reading the image, right? So this is one task. Now to convert to, because this is the original image, right? This is the original image, because we have created the image like this. So what we can do to display the image using this command also, what we can do to display the image in this form, what we can do is we can do the conversion. We will simply change BGR to RGB format using this particular command. Again I am copying it, pasting it to chat box. Okay, so using this particular command, this function cvt color, using this I can do the conversions, means I can do the conversion from BGR format to RGB. Okay, so in this function the first argument that I need to provide, it should be the image whose color conversion I need to do, and the second argument it should be the what type of conversion I want to do. Okay, so like over here if I put cv.color, let's wait. So when I put cv.color, so you can see the complete list of functions available. Okay, like if I come to this lower side, so it is like BGR to gray, means if I want to convert the color image to a grayscale image, that I can do with the help of this BGR to gray, BGR to lab. So different conversion, BGR to RGB, different conversions are available. Only thing is I need to select any of this, right? So with the help of CVT color, I will be able to convert the color format of this image to this. So if I execute this, and now if I display this image, so now it is going to give me the proper color. Now you can see, now it is red, green and blue, and originally also like it is red, green and blue. Okay, so now we have read the image using OpenCV, but we need to make it clear that in OpenCV the first layer it will be of blue. So if we are processing the image using some other tool, so it would be better to do the conversions. Okay, and to convert the image from BGR to RGB, right? Is it okay? Try to execute this, and then after a minute, then I will go to the next step. Okay, so now the next thing is that sometimes we need to display more than one images. Okay, so one way to display the image is to, like over here, suppose if I want to display two images, one img2 and I also want to display img1. So if I write in this form and now if I execute, then what will happen? It will display only a one image, single image. And if you note, it display the last image, img1. Okay, it has not displayed img2, right? So what happened, that first compiler execute this line, this image corresponding to this, it got executed. After that, when this command is executed, then the image, the previous image, like the new image, is displayed on that particular image, on the previous image. So the previous image got replaced with the new one. Now if I do not want to replace the previous image, so what I can do, I can instruct by writing figure plt.figure. By writing this, I am just instructing the compiler or interpreter to display this second image on the new area. Okay, so now if I execute this particular line, then you will see that both the images are displayed. Okay, so let me put this code also. So, and one more thing that you can notice in this plt.imshow, the image that is displayed. So on the x-axis as well as on the y-axis, it gives the dimension of the matrix. Okay, like if I want to look at the location of this, so it will be 250th row, and over here it is around 150th column. So this x-axis and y-axis, it is giving me the idea about the row and the column number. Okay, this we are going to discuss later on, that how we can get the pixel value at some particular location. Apart from this, if I want to display the image somewhat in this form, means in a single window, then I can use subplot. Okay, let me simply execute this first. So over here you can see the image, it is displayed in this format, one after the another, okay, with proper heading. So what I did over here, first I put plt.subplot. Now this subplot, it just help me to, it just divide the complete figure into different portions. Different portions means Like over here I mentioned this number 1 comma 2. So over here it means that I am giving instruction that divide the complete figure in one row and two columns. So one row and two columns. If I put, suppose if I put over here 2, then it will be 2 rows and 2 columns. And suppose if over here let me put 1 and over here let me put 4. Yeah. So now you can see when I put 2 comma 2, it means I want to divide the figure into 2 rows, 2 columns, and then the third argument, it is the number. It is the number that when I divide this complete figure into 2 rows and 2 columns, then this will be the first box, then second box, third box, and the fourth box. So when I mention 1 over here, it means that this image, it will be displayed in the first box. When I mention 4 over here, it means that this image, it will be displayed in the fourth box. Right? It is the reason that it displayed like this. I put plt.title. So whatever I mention, whatever text I mention over here, that will be displayed over here. Right? So in this way, we can like display our output in a better way. Right? So let me copy this code also. You can try to execute this thing also. Over here, this third line, X ticks and Y ticks. If I suppose if I make this as a comment, okay, to make the line as comment, simply select the line or put your cursor on that particular line and press Ctrl/. So Ctrl/ will make this line comment. If you again press Ctrl/, it will uncomment it. Okay, so you can also do the comment from here. Here, add a comment. Not from here. Okay, comment side box. Okay, just leave it. Just press Ctrl/. That will make the line as comment. So now if I make this particular line comment and now if I click, then you will see that the X and the Y axis have the numbers. X is over here. Whereas this over here in the second image, we have put this empty brackets. So empty bracket is instructing the interpreter that the axis, this marking should not be there. So if I want marking, then I do not need to put this. If I do not want marking, then simply put this line. If suppose if I only write this plt.x then it will simply remove the ticks from the x-axis. On the y-axis, we have ticks. Okay, so in this way, you can display the things as per the requirement. Right? Now, after this, we have up to now we have read the image, we have display the image, and the third most important thing, if we want to save the image on our system. On our system over here, it means on our Google Drive. So if I want to display the image on my Google Drive, then let me again copy the path first. I am copying the path, or let me copy the path from here. Okay. So I copy the path over here. Right? Over here I can put any image. Okay, let me put MOD. It will be the name of the image. Okay, up to this will be the path of the image, that is the content, drive, my drive, this. Okay, this will be the path, and this will be the name of the file. This will be the type of the image. Okay, format of the image. And then After comma, we need to put the variable in which we have stored the image. So if I now let me first go to the drive folder over here. In these images, you can see we do not have any image with the name mod. But now if I execute this particular command, and now if I go back over here, I can wait or I can refresh the page. You can see we have this file mod, and one thing you cannot, over here it is png, original file format is png, but now we have saved the file in jpg. Means this reading and writing, it can be used. Suppose if I want to convert jpg image to png or png to jpg, or I need to do any format change of the image, that I can do with the help of just I will read the image and then I will save the image in the desired format. Okay, so simply reading and writing can simply help me to change the format of the image, right? So let me copy this and put in the chat box. Is it clear? Okay. So now if we come to the next topic, uh, after this we will have going to have some break for 10-15 minutes. So image sampling and spatial resolution, as I mentioned in the morning session, if you simply execute this command, it will give you the dimension of the image. First, it indicates the number of rows present in the image. Second dimension, the number of columns in the image, and the third, the number of layer. And it should be 3 for the color images. Why it should be 3? Because BGR format, red, green, blue format, right? So if I execute this particular line, you can see in this image that I have created, in this image we have total of 372 rows, 404 columns, and 3 layers, right? If it along with this, like suppose if I put this bracket, square bracket, and if I put 0, and now if I run, then it will simply give me the number of rows. If I put 1 and if I execute, it will give me the number of column. You can see 404, 404. So if I need to, if I want to have the complete dimension, rows, column, and layer, I can do it using this. If I just want the number of rows, number of columns, or the number of layers present, I can add this square bracket, and inside this square bracket I can put 0 to get the number of rows, 1 to get the number of columns, and 2 to get the number of layers. Now suppose, now this particular command means this one, not print, this part, it can be used. Suppose if I want to identify whether the image or whether the variable img, it carries color image or the grayscale image. So to check that, simply what I can do, I can put a condition like if img this is equals to 3. If this condition is true, print, and I can put image is colorful. Okay, otherwise else I can put image is grayscale. So if I run this, it is saying image is colorful. Okay, so because remember, we need to automate the things. Okay, it is not like that I am going to see the image with my eye and then I will say, okay, the image is color. I need to do all the things programmatically. Okay, then only it will make the system like automatic. Okay, so that we can do with the help of this particular thing. Okay, so again let me paste it on the chat box. Now if I suppose the original image it is of this, right? If suppose if I put 100 over here, right, and I execute, let me copy this path. So if I execute this line, with the help of this function, I am this resize, I can modify, I can change the size of the image. Means I can change the number of rows and number of columns present in the image. You can see in this particular function, the first argument that I need to put, it is the input image. 2-3 minutes. And in the second, over here I just need to provide the dimension, number of rows and number of columns. Okay, so I execute this line, this changed the image, and the new image it is in img3. Then I display this and I also put it in the drive. So over here it is medium, and you can see the structure because the size is reduced, so there are distortions in the image. If I further reduce the image again, and it is stored in this LOW, so you can see this, right? So this is the special resolution, that when the number of pixels are high, so in that case, when the number of pixels are less, then the clarity it will be distorted, the edges it will be distorted. Okay, so we can do the resizing with the help of this particular command. Let me put it in the chat box again. Okay, so any doubt up to now? So up to now we have discussed how we can read the image, how we can display the image using plt and using subplot, and how we can save the image. We have discussed about how we can how we can check the dimension of the image, how we can use this thing to identify whether the image is a colorful image or the grayscale image. We have seen how we can change the size of the image, and with this resize we have also seen that how the image get distorted, and the reason of this distortion in the morning session we have discussed that as the number of pixels are going to reduce, it will become difficult to reflect the actual boundary of the object. Okay, so it is due to this reason that it is quite difficult to replicate the exact boundary of the image, right? Now after this, again the conversions. Okay, because like up to now we have discussed about how we can convert BGR image into the RGB. Okay, and remember, like if you are working on platform like MATLAB, over there if you are going to read the image, it will be read in the form of RGB. In Python using OpenCV, it is BGR. So you need to make it clear, and you need to know that how your image is going to be read. Now when we do the image processing now, and when we see the color image, now the importance of the color is mainly on the visual aspect. For example, suppose if I want to simple example, if I want to classify between the chairs, then color is not at all important, as I discussed in the morning session. Okay, but so color is not important for making a decision whether the object is chair or table. Now the question is, when color is not important, then why to use the color information? It would be better to convert the image into the grayscale, because if we convert the image into the grayscale, something in this form, then we are going to reduce the number of pixels by 1/3. Okay, because suppose if the dimension of the image, number of rows and column in the image, if it is 100 by 100, 100 rows, 100 column, and there are 3 layers of red, green and blue, right? If we simply convert a color image into the grayscale, then in the grayscale we will have just 100 by 100 pixels, total 10,000 pixels. Whereas in the color image, to keep the color information, we need 3 layers, whereas to remove the color information, we just need single layer, right? So when color is not important, in the applications where color is not important, it is always better to convert the image into the grayscale. Another example of the like advantage of converting the image into the grayscale, like suppose if you are looking at some pencil sketch that is drawn by some artist. Okay, like even if there is no proper colors, only the pencil shade is there, okay, still we are able to recognize the celebrity or the person whose face is drawn, right? Even when color is not there. So the color information is not relevant in most of the cases. The color is mainly required when we want to enhance the visual aspect. Okay, because we humans like color, we want colorful life. Okay, so to beautify the atmosphere, to beautify the things, color is required, but to do the processing, we can remove the color. So to remove the color, of course, we need to do the conversion, and for that conversion, again we can use the same function cvt color bgr to gray. So simply if I execute this particular line, then it is going to convert this. Let me copy the code. Okay, so now over here, let me, if I do not put this thing, it is quite important. If I want to display the image in grayscale format, then this C map equals to gray is very much required. If I do not put it, then it will display the thing in color form only. These colors that are displayed over here, it is not the actual color, it is the pseudo color we used to say. Okay, and this color, like the interpreter, it just put it on its own. Okay, to avoid this, we put this, so that by writing this, we are just instructing it that the color, it should be in the gray form, grayscale form. Okay, so it will keep the color in gray scale form only, right? So this is the grayscale image corresponding to this image, okay. Now in the as I told you again, like if I again check the shape, this is image 5, right? So if I now check the shape, you can see dimensions are same, number of row and column it is same, 372 into 404. In the actual image, img1 dot shape, dimension is same, row and column are same, only this third dimension over here it is 3, and over here it is not mentioned anything, it means it is 1, means only single layer is there. So this is the grayscale image, and the benefit of grayscale image is that complete information is there. If we do not require colors, then complete information is there about this image also. right? Now apart from grayscale image, we can also convert the image into binary image. Now remember, when we say like we used to call the old movies as black and white movies or black and white photos, but not that technically binary images or black and white images are the images that have only two colors, black and white. There should not be any gray shade like this. Okay, so in the same way, binary image or black and white image, they should have only two colors. One is black, another is white. There should not be any color shade. Benefit of binary image is that we can have a clear picture that what is the location of the object, what is the location of the background. But we may suffer from the loss of the information. Like suppose, let me first, like using this particular function, I am just converting the image into the binary. Okay, so the image that I am converting, it is going to be stored in threshold 1, second threshold 2, 3, 4. Okay, so I am going to discuss this, but let me first run this. So now you can see in the morning session, I told you that over there I keep the threshold in the middle. Like I told you that if the value is less than 120, then make it 0. If the value is greater than 120, then make it 1 for the to convert the image into the binary image. Right? Over here with threshold, with this value, it means that if the once we convert the original image into the grayscale image, and if the value of the grayscale pixel, if it is less than 50, then make it black. If it is greater than 50, make it white. Right? So over here threshold is 50, so this is the output. Over here threshold is 100, so this is the output. Means it means that the pixel value of this particular ball circle, it is like which appears white over here. So the pixel value of this, it must be between 50 and 100. It is the reason that when I put the threshold as 100, okay, so this circle, it appears in black form. When I put 150, this circle also appears, and it means that the intensity or the pixel value of this, it must be between 100 and 150, right? And if the threshold is 200, then also I get this same. So when I convert the grayscale image into the binary image, so on one hand, suppose if I want to determine the location of this particular ball, I am able to determine the location. But if I do not want to, over here I lost the information of these two. So if it is okay, if as the application for some particular application, if I do not need this object, I only need this one, so for that this is best. But if I also need the information of this ball, okay, this blue one also, so in that case I need to keep the threshold as 100. If I need to the information of all the three balls, I need to put the threshold as 150, right? So converting the grayscale image into the binary image, it will again reduce the complexity in the sense that it will, as I told you in the morning session, it will require less storage, okay, because one pixel will be represented by only one bit. But because over here we just have two colors, this black and white, so everything will be reflected just by black and white, and there will not be any gray shades. And if shades are not there, so like over here all three circles, they look exactly same, but in actual they are not same. In the grayscale image, it also appear from here that it is not same. So if for some application this may work, but for some, if in the application where we want to discriminate between these three circles, in that case this will not work, only this will work, right? So again let me okay. Now this particular function cv.threshold, it will help you to convert the image, grayscale image, into the threshold, into the binary image. So over here this will be the argument, that the first argument it will be the grayscale image, second it will be the threshold value. Okay, threshold value means if the pixel value is less than threshold, then the output will be black. If the pixel value is greater than this, output will be white. Third argument, it will be the maximum value which will be assigned to the pixel exceeding the threshold. So over here we can put the maximum value, means for white, since for white is represented by 255 for 8-bit image, so it is the reason that I put 255 over here. I can put 120, 130 also. So in that case it means that all the pixel having value greater than 50, they will be represented by 120 if I put 120 over here. And then this is the method with the help of using which we are converting the image, okay, into the binary image. So there are different functions available over here. We are not going to go into their detail, okay, because our purpose is just to do the conversion from grayscale to the binary image. The output of this function, it will return, the image will be returned over here. So this threshold one, it will carry the output image, the binary image, right? So if I copy this and put it in the chat box, so you can copy the code and you can try to implement this. This code, and it is also same thing, just how we can display the different images in a single figure. Okay, so due to the limitation of the time, I am going to skip this portion. Now up to now we have read the image from the Google Drive, we have do the conversion. Acha, okay, I am copying the code again. Oh, वो आ नहीं रहा है, rate threshold 3. Okay. I need to put the code in segments. Okay. Please. Okay, so I have copied the this code. Okay, so after this, now up to now we have read the image, we have displayed the image, we have saved the image, we have done the conversion from one color space to another, right? Right now okay, so over here now we will try to create the image, okay, because we know that image is just a matrix, right? And if it is a matrix, then of course we can create the matrix, we can have any matrix. Okay, so over here we are going to try to create some images of this form, like this check boxes. Okay, so this we are going to try to create, right? So to create the image, because image is just a matrix, so over here with the help of this particular function, okay, like that a code. If I simply write this, a equals to np dot once 2, 3. So over here you can see that with the help of this particular function, I can create a matrix. And the dimension of the matrix is 2 rows and 3 columns. You can see over here. If I want to create if I want to put a data type of this, okay, like over here it is int. If I just try to determine the type, is numpy d array, right? If over here, if I put this np dot uint8, and now if I run this, okay, it is not okay. np dot a dot d type. Just a minute, I forward the command d type a dot np dot. नहीं, उसके मैट्रिक्स के अंदर के जो एलिमेंट्स है ना, उसका मैं देख रहा था कि क्या होता है. a dot d type. Let me Google it. Just a minute. New Python d type. Okay. Okay. Bracket should not be there. So over here you can see the data type is float, right? And now if I again put this and I put this another option, np dot this, right? And let it be b. Let it be b. And now if I execute this thing, then this float 64, it is for this print, and this for this, it is uint8. Because our image, as we discussed in the morning session also, that our image, if it is stored if the pixel is represented by 8-bit, then the format of the matrix element means the format of each pixel should be uint8. Uint, it stands for unsigned, u stands for unsigned, int for integer, and 8 represents for 8-bit. Okay, if I put 16 over here, it means I execute this, it means that the unsigned integer 16, that 16 bits are used. Okay, so over here, since we are creating an image, and in the image, if we want to create a image with pixel depth as 8-bit, okay, we want to represent pixel with 8-bit, so over here I mentioned this. Okay, and so this is going to create a matrix of dimension 10 by 10, 3, means 3 layers will be there, and this will have a value 1 1 1 1, right? Means if I execute this, it will simply have all ones like this. Now if I multiply, suppose if I multiply this with 255, and all the values, it will be 255, right? So over here I create an image of size 10 by 10 by 3, means color image. Type will be uint8, means it will be the type of the matrix element, and I multiply it with 255 so that I will get this type of the matrix and of size 10 by 10 by 3. right? Now after this, with the help of this, as this word is indicating concatenate, means we are going to combine two things. What we are combining over here? We are going to combine the two matrices. Over here, this is the function that is going to help us to do the to combine the two matrices. Okay, so what are the two matrices that we want to combine? It is mentioned as the argument. One matrix is IC1, means this one, with all the values 255. Another matrix is 255 minus IC1, means over here the matrix is 255 minus IC1, means all the it will be complete 0. 255 minus 255 will make it 0. So the IC1, it is white, this it will be black. Okay, over here I mentioned axis 1. With axis 1, like in this axis 1, axis 0, this second argument will indicate that how I want to combine. I want to combine the two matrices horizontally or vertically. If I want to combine the two matrices vertically, then I will use axis 1. If I want to combine the matrices horizontally, vertically it will be 0 and horizontally it will be 1. So like suppose if I put this as a comment and over here let me put IC2. Now if I execute this line, you can see with the help of this I concatenate this particular matrix IC1 which I created using this, and after that 255 minus IC1 means size will be same, but all the values in place of 255 it becomes 0. Okay, and it is this matrix is added just after this matrix. Okay, when I mention x is 0, now over here in IC3, what I mentioned IC2. IC2 is this, right? So this complete is IC2. Second matrix is 255 minus IC2. So 255 minus IC2, it means that this white portion it becomes black, this black portion it becomes white, right? And I combine it with axis 0, means vertically, and since I combine it vertically, so now if I execute this particular line, then I will be having, okay, this should be IC3. So I will get this thing. Is it clear? Any doubt in this? I copied the code over here.
Shut down कर दो PCs.
Nidhi Chauhan, you can unmute yourself. If you want to ask any question, you can ask. Okay, so in this way we can create the matrix, right? Over here in the same way, following the same pattern, we can create the complete chessboard. Okay, I will share this code also with you all in the chat box. Okay, and over here in the chessboard, because we have 8 rows and 8 columns, so this first matrix, this first loop, it is to create the single horizontal line, because in the single horizontal line we have alternative white black. So this single line it will be created using these 3 lines. After that, using this we are going to create the first we have this line, then we are going to invert the image and we will put this, then after this we will put the inverted form again. So continuously we will keep on inverting the image, okay, as mentioned over here. So with the help of these 3 lines we are going to create the rows, okay, and then we display this image. In this particular thing over here we just multiply with 255. Over here we multiply with
not 255, we multiply with different color. This is for B, it is for G, it is for R, or sorry, R, G and B. Okay, so the first layer element in the first layer, it will be multiplied with 255. Element in the second layer will be multiplied with 120. Element in the third layer will be multiplied with 0. Right? And then we are going to do the same thing that we did for this particular thing. Okay, and then we display. So over here, since we are not multiplying with 255, so we get a color over here. Right? Now, in the next thing, over here I keep the numbers fixed. But what we can do, we can generate this number randomly. So using the random number generation, like suppose if this is, let me put the code. So if this is the thing, if I execute this particular thing, I execute it, it generates 74. If I again run this, it will generate another number 204. If so, randomly each time I am going to run it, it is going to generate another number. So over here for this 255 120 0, I generate the numbers randomly, and random generation will just each time I am going to run this code, it is going to display different colors. Okay, so you can see each time I am so we are getting different color. So this type of image we can create. And over here there are only two colors. Over here in this portion, I just make the colors of all the boxes randomly. So if I click on this, then each time the colors of all the boxes, it will be randomly generated. Okay, and why it is important that you should know how to create the image? Why it is important? Because if you are able to create the image, then it means that the basic fundamental regarding the pixel values, how the pixels similarity will work, how we can modify the pixels when we talk about the image enhancement or edge detection or segmentation. So what is the role of pixel values? That will be cleared only if you know how to generate the image, because generation simply means that we are creating a matrix. Okay, so this is all about this session. Okay, so any doubt, anyone? Apart from this, like this reading an image and video from webcam, I am going to share this code also with you all. After the workshop, I am going to put this in GitHub and then I am going to share this. Okay, so using this code, like using the webcam, as I told you that over here we are using the resource of the Google, and everything we are doing from the Google Drive. So if we want to capture the image from the webcam, then Python should be installed, should be installed in our system. Okay, using Google Colab, there are ways to access our webcam, but for this particular workshop, we are not going to stuck for that thing. But if you just simply run this particular code, so this code will help you to capture the images from your webcam. Okay, you can even over here, this is with the help of this command, you can capture the image from the webcam. In place of this, even if you put the path of any video, means the video that is stored in your system, if you put the path or the file name of that particular video, then also that video will be read by this particular thing. And the best thing, suppose if you want to create a black and white picture of a color image, if you have a color video, okay, you want to create the black and white, you can do it just by using this particular code. Okay, just what you have to do, the frames that you are reading using this particular command, the frames that you are reading, you just for each frame, you just have to do the color conversion. The color conversion command, cvt color, that we have discussed. Just you have to execute that particular command, okay, for each and every frame that is captured by the camera or that is there in the video. Okay, and the output at the end, you can save the video using this particular program. So your input, it may be the color image, your output, it may be the a black and white movie. Okay, or your input can be the normal, like you can rotate the video by 90-degree, means it is not rotation of the image, you can rotate or flip the complete video using these two codes. Okay, so this is about first session.